Live here Friday afternoon, 4 o'clock, and overlooking the city of Honolulu in our ThinkTech Hawaii studios. Ted Ralston here hosting our show, Where the Road Leads. And those who've seen this show before know that it leads in many different places. Today it leads to a fantastic domain of convergence. Convergence in the North Pacific Gyre, I might add. And that convergence includes the following components that are converging: interests and efforts in Switzerland, United States. One of our colleagues, Chuck Devaney up in the Arctic Circle, may be joining here in a minute, Hawaii. And this deals with UAVs and drones, which is a common subject on this show for those who are our habitual viewers. Anyway, what does this mean? Convergence in the North Pacific Gyre. And with that, let me turn to our guest today, Dr. Dave Johnston, from the Duke University, ex-UH, ex-NOAA, ex-SOEST, and here in Hawaii.
Yeah.
Dave, thanks for coming on the show. This show, by the way, is defined by the guests who come on it, not by the host, let me tell you, okay? And we keep
well, thank
changing,
you.
we keep increasing that exposure every week.
That's great.
Unpack that story for us a little bit about convergence in the North Pacific Gyre, Dave, and what that means in the context of your presence here in Hawaii.
Yeah, well, I mean, you know, convergence can mean a lot of things. And in this case, we're talking about a lot of stuff that revolves around marine debris. And specifically these kinds of pollutants, plastics, that enter the ocean in various ways and end up accumulating in places, areas of convergence, and in doing so have kind of increased public awareness of that kind
This
of
is
publication.
plastics that float, right? Things that are discharged out of stream runoffs, out of landfills, out of anything that gets into the ocean.
Yeah,
And
yeah.
it ends up converging in some certain place, like the North Pacific Gyre.
Absolutely, yeah.
That's the stuff that, how about the stuff that sinks?
Well, it converges on the bottom.
On the bottom, okay. And it's not tied to the North Pacific Gyre necessarily, so we...
No, and in fact, the plastics that we see in the North Pacific Gyre, you know, that's not a singularity. We have plastics in all the gyres in the ocean.
How many gyres are they in the
5
ocean?
big gyres.
And they're related to the global circulation
Absolutely.
in some way that
Yeah.
the hydrologists would be excited about?
Yeah, our oceanographers,
Yeah.
you know, that's their domain. And,
So there's 5 gyres around the world, around the globe.
Yeah, and so we're here talking about the North Pacific and thinking about something that's pretty common, I think, for the experience for people in Hawaii, and that's seeing plastic on the beaches.
So the opala that collects in the North Pacific Gyre degrades or somehow fragments and then ends up on our beaches.
Yeah,
Some of it does.
Some of it does, yeah. And I like to think of the Hawaiian archipelago as kind of a comb that sits in the ocean, and as that gyre spins around, you know, it combs the debris out of the ocean and it collects up on the shores. And so we were just up at the Waimanalo Beach Park, walking around there, trying to plan out some things for sampling, and you don't have to walk very far before you look down and see little pieces of plastic, maybe a bigger piece. It's everywhere.
We live on Waimanalo Beach ourselves, right down past the park, and we see the confetti-like small little pieces of multicolored plastic all over the place.
Mm-hmm.
We see those, what look like coffee filters. They're black conical gizmos with holes in them and some strings coming out the bottom. I was told they're part of an Indonesian shrimp raising activity. They're flotsam that's come clear across from Indonesia.
Yeah.
So stuff collects on the beaches, and you say it's the Hawaiian Islands become a comb collecting all that.
Yeah,
what about the stuff that goes between the islands? What does that end up?
Stays
Some
out.
other beach, right?
Yeah, stays
it ends
out
up
there.
somewhere.
Maybe goes around a few more times until it encounters a shallow spot and fetches up on a shoreline.
Does the gyre turn in the same direction all the time?
Yeah.
What,
Yeah.
is that cyclonic, anti-cyclonic?
So yeah, it's turning like the clock.
So it's the same direction as the wind in effect.
So the trades are coming this way towards one, essentially, yeah. And so you know, we continually generate more plastic on the beaches, and I think it's good to keep in mind that a lot of the things that we make out of plastic, we design them specifically to last for a long time.
And
they do, right? People love plastic because it's hardy and resilient, durable, And when you think about that, we've designed a product that stays with us pretty much forever. So most of the plastic that we've created is with us still. And even the stuff that goes in the ocean, it may not be the same size or same shape, or maybe not even the same color, but it's still there.
What do you think the percentages of that floats versus that sinks? Or plastic's attached to something heavy and goes down with the heavier piece?
Yeah, to tell you the truth, I don't know. It's a great question.
There could be a lot of stuff on the bottom.
Yeah, there is, and there are some great studies that are looking at plastic deposition in the bottom in places, and in some cases, that could be good for animals. We were talking a little bit earlier about albatross, and albatross are a species that we know collect a lot of plastics when they're out at sea, and a lot of that is because it floats and it biofouls, so it gets things living on it that make it maybe smell or look a little bit like food. And albatross eat that, and if those things sank, then they probably wouldn't eat it. Now, it doesn't get rid of the problem. We're still putting the plastics in, but they would be going to a different place. And so, there's a lot about how the things are configured that defines how it interacts with the ecosystem.
Interesting. And then the association you got here is your own training as a biologist, marine biologist. But then the organization you're working with is the Race for Water Odyssey.
Yeah.
A recently created advocacy group attempting to discover, expose, articulate, and get support for some action to deal with this problem. Talk a little bit about Odyssey.
Yeah, so we're involved with the Race for Water Foundation, and they have an Odyssey. It's focused on a kind of an exploration of the ocean using a very, very high-tech sailboat that can travel very rapidly. And what this allows the Odyssey to do is essentially visit all of the oceans and islands that are associated with these gyres, and connect a little bit of science and do a lot of outreach and try and raise awareness about these issues. And so the Odyssey is traveling around. It's been through the North Atlantic. It's now in the Pacific, and come back here to Hawaii to spread the word here. And a lot of people here are fully aware of it. So it's nice to come to a place and see that locals are concerned.
I had some interesting thoughts. We were at your press conference yesterday down in Cavello Basin. The boat's going to be here till what, about Wednesday or so?
Yeah, I think they're going to leave Wednesday or Thursday.
And the public can come on down and take a look at it. They can't get on necessarily, but they can see it at moored down at Cavello Basin.
Yeah, I think so. Yeah, and
Okay.
and in fact, even just from, just from the street there, or where all the whale watch boats and stuff are, you can actually look right across and see it.
What struck me after seeing it at the dockside yesterday during the press conference, thinking about it overnight, what struck me was that there's a correlation between that and the Indy 500. The Indy 500 is a really exciting thing for people who want to get into cars, as opposed to, say, the standard Chevy station wagon or something like that, which is relatively boring.
Yeah.
But Indy 500 is not boring. It's exciting, it's cutting edge, it's new things. And in the same sense, having that vessel, which is totally high-tech, it's a very exotic racing yacht, basically.
Mm-hmm.
Doesn't look anything like your standard research tub.
No.
Which is a repurposed Navy vessel of some kind.
Often, yeah.
You had to make 7 knots on a good day.
Yeah.
And has all kinds of funny-looking things all over. This looks like something you'd like to be associated with. So kids out there who are in high school or in college or thinking about this as a career, this might inspire them in a direction that that enhances the science aspect, because it's a very interesting way to approach this discovery that you're in the middle of, discovering what the opala in the ocean is all about, how it originates, and what we can do about it.
Yeah,
So,
I really do believe that it's very inspirational, and it's I think the Odyssey is a really wonderful connection or intersection between a really important environmental problem, an amazing sense of exploration and adventure, and the use of new technology to be able to try and both spread the word quickly and to be able to conduct some cool science.
There's another kind of correlation here. That vessel is either fiberglass or carbon fiber, I would presume.
Carbon fiber.
Held together by petroleum products, which are the epoxy and such that ties it together, which could have been plastic in the manufacturing
I hadn't-
process somewhere. So
I hadn't thought about that, yeah.
There's a relationship there.
Yeah.
So this is a good use of plastics, and it's helping to point the finger at what we have done to ourselves in the over dependence on plastics and such.
Yeah.
So talk a little bit about the Race for Water organization. How did they come into existence, and what's behind that?
Yeah, so the leader of the foundation, Marco Simeoni, he is an open ocean sailor, and I don't know him well. I've only met him a few times, but he spends a lot of time on the ocean, and I think has has seen this and identified it as a problem, and so he's invested some of his hard-earned dollars into building that boat and taking on this as a personal mission to try and push things along. And the Odyssey is just the first step, and I know that they have a lot more in plan, for the future. This first exploration and kind of getting the word out is going to be followed up by some research and doing other things that we hope will push us a little bit farther down the line when it comes to understanding not just where the plastics are or how dense they are or how many pounds or kilograms there might be in certain places, but thinking more deeply about how they might affect different ecosystem components.
So this then gets back to the issue of there's a demand function that's drawing the plastic manufacturers into the game, and plastics are being made probably cheaper, faster, more precision, and this sort of thing as time goes on here. Plastics everywhere. So we, the people in the world, are generating the demand function that causes plastics to get made. We have to generate the demand function that says we got to do something about these plastics and make sure that they don't last forever, or that they're reharvested in some way, reprocessed. Can these plastics, if we had access to them instead of putting them in the ocean, and we need to talk about how they get in the ocean in the first place, but is the plastics chemical capability at the point of being really reprocessed at this point in time?
Yeah, I think that there's, I don't know exactly what forms, because anyone that recycles knows there's maybe 7 different kinds of plastic that they can recycle in different ways. But I do know that there are new businesses cropping up all the time now that take advantage of these recycled materials to do everything from making polar fleece for people who are in cold weather. Maybe Chuck's wearing something made out of it.
Or you guys on the Odyssey when you get to the North Pacific.
Right. But also things like skateboards or other things, right? And I do know that those things are happening. I don't know much about those things, and I'm glad that they exist. But I think that's an important thing to think about. Recycling can be costly, and it also requires water in some cases. And so we have to...
Probably a lot of electricity.
Yeah, and exactly. And so I think not only do we have to think about how we move plastics from places where we don't want it to places where we can make use of it, but we also have to think very intelligently about how we make use of those things so that we don't create more problems as we spin along. Because we're known to do that.
This is a really interesting situation. I was just thinking about this yesterday again after we first met at the press conference. Well, at least when I was a small kid, plastics weren't everywhere. They were not on rolls of cellophane or shrink wrap or all these things we have as convenience items now. There was no such thing as Ziploc bags. Wax paper was what you used to put things together with, maybe tape and a rubber band or something. And when you're small, you somehow get the picture that, hey, this thing looks like it's pretty durable. It's going to be around a lot longer than I am. And you're sort of cautious about it. As you become older, you get jaded or something, and you just more plastic, buy it, use it, toss it away. Someone else's job, or pass it on to someone else.
And it's cheap.
So it's cheap.
So you don't worry so much about your pocketbook.
Yeah. I was thinking that maybe a measure here is to have everybody on the show here use one less Ziploc bag per day, and it won't affect their pocketbook at all, as you say, but it would start affecting the demand function on where how this stuff gets made.
Yeah, I'd also encourage everybody to just think a little bit about the plastic products that they use, and you want to do that. Thinking about things that they use every day, like toothbrushes.
So an ultimate goal of yours is to tie together the stuff that's floating in the ocean, how it got there, and where it came from in the very original place, and then see if we can't intercept that flow somehow with some form of a directed recycling. Or and what we'd like to talk about next after the break here is just how does all this plastic get into the ocean in the first place? I mean, nobody goes to the ocean and dumps it out.
Wow.
So there's
not around here.
I hope not anyway. So we'll come back to that after the break and talk about how it actually gets in the ocean in the first place.
Great.
Thanks a lot.
Aloha, I'm Hunter Hevelin, host of Sustainable Hawaii here at ThinkTech Hawaii. You can tune in every week on Thursday at 2 p.m. to see interviews with sustainability professionals from around the state and even further abroad, learning about activities with water management, food security, waste management, and a whole host of other fascinating opportunities to get engaged with making a greener island. So if you're interested in making the transition from consuming individuals to communities of producers, check us out every Thursday.
Hi, aloha. My name is Chris Leatham, and I host a show called The Economy and You. The show plays every Wednesday at noon, and on my show, I bring on guests who are interested or working in the technology space. And so I'd like you to come and watch the show and learn with me about all the sort of exciting things that we're doing in Hawaii to build and grow our economy ecosystem. So I'd like to say aloha, and I look forward to seeing you on the show. Thank you.
Friday afternoon, folks, downtown Honolulu, where the road leads. This week, the road leads to a fantastic convergence. Convergence and a dissection of that convergence with our guest, Dr. David Johnston of Duke University. And we spoke earlier of, before the break, about what Dave's been involved in here with the Race for Water Odyssey and the really important issue of discovering the whole systematic process of how the North Pacific gets filled with floating plastic garbage, which then gets fragmented and ends up back on our beaches here in Waimanalo or wherever we might live. So we were talking about the fact that the 5 gyres in the ocean, through their circulation process, end up collecting material. A lot of it sinks, we think.
Oh, yeah.
That doesn't sink, we see, and it ends up on our beaches. How, Dave, how does this material get into the ocean in the first place?
Yeah, I mean, it enters the ocean through multiple pathways. You can imagine runoff from storms. If you walk down the street here, sad as it is, you'll see plastic wrappers, you'll see all sorts of things that are kind of kicking around. And you have a big rain, you end up washing stuff into the ocean.
So things we think are insignificant, like a little gum wrapper or something like that in the gutter, ultimately ends up in the ocean.
Yeah.
It contributes to this larger...
Yeah, absolutely. And so it's as simple as that. Sometimes it's very large-scale disasters like tsunamis that sweep incredible amounts of water over places that it's not normally at, and can sweep a ton of material, not just plastics, but all sorts of things into the ocean.
And to that point, it's an interesting point, because even though we only see the tsunamis that affect us here, they're happening everywhere. Mm-hmm. And so there's various forms of storms and such. The Earth's getting washed a lot.
Yeah.
Getting disturbed a lot. It's like those when you were a kid, you probably had that diamond head thing where it had snow come out of it. You know, you turn it over and snow comes down on diamond head. So that happens a lot. So the disruption of a stable environment by storms of various forms, flushing basically the continents, is what's happening. Is that?
So yeah, that's definitely one pathway. There's also accidents, things like ships dumping material accidentally, a container knocked off a ship. Showed me we talked about the Moby Dick book,
yeah.
Right? So we definitely know that happens. It's not just the shores of Hawaii. I spent a lot of time on the central coast of British Columbia and southeast Alaska. And when you walk down the beach there, you'll find a lot of plastics, shoes, all sorts of things that have...
Which suggests containers, doesn't it?
Yeah, because it's not like they appear to be well used. They just are there. Who knows where they came from, but that's one other pathway. And there's a lot of places in the world where, sanitary capabilities are, we just don't have the same kind of attention to detail that we are lucky enough to have here in the U.S. And so people make do, and they have landfills that are often, permeable to plastic, and so you end up having, this kind of stuff enter the ocean through a variety of pathways, and And once it's there, it kind of floats around and it stays there.
And ultimately, the Gyre system will pick it up in a very slow process. Everything will converge in one of the 5 gyres in some
Yeah,
way.
it kind of floats around there, and you know, it's in various forms, big pieces of plastic, little tiny pieces of plastic,
And containers.
absolutely containers, yes, and yeah, those are frightening things to see when you're at sea for sure. You want them to be on the ship, not in the water.
That's an interesting point. I was working with some maritime domain awareness folks in the past, and one of the issues was containers and in the ocean, and I never understood how the shipping business would allow that to happen. Find the answer. The crew on the ship, their job is to get the ship where it has to go. Someone else packed it and loaded it, and the crew on board ship can't actually deal with loose containers. It's somebody else's problem. So the same issue as somebody else's problem applies to containers in the ocean as well.
That's interesting, yeah.
And containers become obviously a collision problem for vessels coming through.
Yeah.
And all you see is the little you know, trapezoidal point of the container that may be still floating.
Yeah.
The rest of it is where the damage is going to get done.
Yeah,
It's-
kinda like
you
an
can't see.
iceberg.
It's like an iceberg, a little metal iceberg,
That's
right?
right, yeah.
Hanging down there under the water level.
Yeah, yeah.
So, in regard to the relationship between beach collection of the combing effect, as you described the Hawaiian Islands chain to do, how will you be collecting information on the beach besides just going through sand filters and this sort of thing and seeing what ends up in the filter?
Yeah,
I understand you're going to use UAVs in this domain, and that's very interesting to this show.
right. Yeah. Well, it's high tech,
You
and
bet.
and it shows a lot of promise for a lot of different things. So yeah, we're really interested in that. That's really my deepest interest in this as a way to contribute to this particular mission. So the Race for Water Odyssey is visiting these islands, and they're doing a standard beach sampling protocol where they look at the microplastics and they sample the beach in a traditional manner. One of the things that we were engaged with early on the project was to try and think of new ways to do this, ways that might increase our efficiency, ways that might allow us to use inspirational technology, just like the actual boat, the Race for Water Odyssey boat, to get people excited about how to tackle this problem. And so when the Race for Water team approached us, we were really excited about trying to use unmanned systems, aerial systems, to be able to try and estimate the density of macro debris on beaches, and to try and think up new ways to be able to do that efficiently. So using, you know, maybe not just visible imagery, but using spectral imagery that's getting closer to the infrared bands to try and see if plastics are reflecting differently in those wavelengths, or how we might be able to use combinations of light that's reflected back from beaches to understand where plastics were versus, you know, the background beach or shoreline or seagrass or whatever might be there. And so, so that's really the part that I'm excited about. And so when our team hits the beach and they do the surveys, they collect a bunch of data and they send it to me. Sometimes it comes on a USB stick in the mail, or sometimes it comes over the internet. And then myself and my students go to work.
Well, you remain back in Duke in North Carolina and receive all this information by various means and then process it there in support of the guys who are out in
Yes.
the ocean and on the beaches doing the beach combing.
Yeah, absolutely.
Okay.
Yeah, that's exactly it. And so we take those images. You know, the drone, we use a fixed wing drone, not one of the multi-copter type platforms, and it takes a bunch of images as it flies over the areas. We get that imagery back, we stitch it together into an orthomosaic, a larger picture that combines all those into one. And from that, we can develop a reflectance map in different wavelengths and start looking for plastics. And this is all done also in coordination with the beach surveys, so that they can make mark locations of where the big pieces of plastic are, so we can start to ground truth.
And yeah, you could get
effectively.
some of this material, take into your lab. You could ground truth it from different levels of illumination, different orientations of the sun and this sort of thing. And
Yeah, we've been doing that. So I've had undergraduate students working with me. I'm very lucky to work with an incredibly brilliant group of undergraduate students that are helping do this. And so I've had a student who's built targets with different kinds of plastic, and we've looked at those reflectances in the bed, you know, doing bench tests and during flights, and we're able to actually see what size of plastics we can resolve and how they reflect. With the green bottle, a clear bottle, a net, some rope, all sorts of different things that.
Interesting. Now, this is really interesting. And Chuck Devaney, who is up north of the Arctic Circle, and I think he's in such an internet denied environment, he's not able to join us by Skype. We'll be back here. He's doing some training for UAV operations in agriculture north of the Arctic Circle. I didn't think anything grew up there, but something must.
Yeah, lichens.
And Chuck is quite an expert in the fixed wing use and mission planning and multispectral extraction and such from imagery. He's done a program here. His master's thesis at UH was all about beach erosion and identification of accuracy or determination of accuracy without using ground control points, and various ways to use SFM, and structure for motion, and other technologies to help pin it down so you don't have to go out there and locate a particular point on the ground. You can infer it from other sources. Chuck's done some work in multispectral on vegetation and such, NDVI and things like that.
Right, which would make the agriculture connection for sure.
Absolutely. Yeah. But he'll be here next week. He'll be arriving on Monday. So just before you leave, I'll have a chance to actually get together.
Oh, that'd be great. I'd love to
get you a copy of his thesis, and then maybe there's some tie here that would work well.
Yeah, that's very much at the intersection of my interests too. I mean, we're very interested in using the unmanned systems for plastic work, but at the same time, we're using them to count seals in extreme environments. We're using them to try and start understanding change in shorelines, very much like what he's been working with. And in fact, at the end of this month, we're going to have a workshop at Duke University where we're bringing together all of our local scientific partners and agencies, state and government agencies, to actually scope out a training facility and a platform facility that we would have in our region that would allow us to support researchers that want to engage with this kind of technology in their work, and allow them to get trained and allow them to have access to a series of multi-copter and fixed-wing platforms that they could go and use in their research. And we're very excited about the training program because, there are lots of training programs. Many of them are associated with agriculture, and the one thing that you are not going to get if you go to North Dakota for UAV training is what it's like to be over the ocean, and it's different. And
we could somehow tie that together with what University of Hawaii is doing in conjunction with University of Alaska. University of Alaska is the sort of the coordinator of a three-state organization called Trans-Pacific UAV Test Site. It's the FAA test site, so Alaska sort of sits on top of it. Hawaii and Oregon and now Iceland which is a 52nd state, are part of it.
Nice.
But the extreme environment is the reason why those states were picked and are together.
Right.
But very soon we will have the ability to generate student programs with a COA that goes pretty much anywhere in the state, which goes all the way out to Midway.
Right.
In a 4-day NOTAM notice. So there's a lot of flexibility that will come into the picture as long as we stay below 200 feet. And I'm guessing that below 200 feet won't inhibit your operation all that much. We'd have to balance the speed and the periodic
your overlap for photos.
Overlap, right?
Yeah, absolutely. Yeah, and I think that we can work really well within those parameters and generate incredible data.
In regard to data analysis and management, that's what really is the end of the day here, is how do you extract information out of this data so we don't sit and take data for the sake of taking data and not do much with it. After we come back from the next break, let me introduce to you the idea of something beyond structure for motion that is some software that's right down the street from us here at a company called Oceanic, but I'm sure you remember them from your days at SOEST. We can generate a meeting with them before you leave. There's some incredible analysis extraction software that can probably speed up dramatically the analysis of imagery in stills or even from high-rate video. We'll talk about that when we get back from the break, folks.
Sounds great to me.
Okay, 1 minute. We'll be back.
Aloha, my name is Miley Scarpino, and I'm the host of the Empower Hour. If you're interested in health, nutrition, fitness, here on the island of Oahu want to learn more about places to train at or different trainers available, then watch my show on Fridays at 3. We have a great time, and I hope that you'll come join us. Much aloha. Now go get swole.
Okay, I'm Jay Fidel, that's Ray Starling. We co-host a show called Hawaii, the State of Clean Energy, every Wednesday, 4 to 5 p.m. It's really interesting. You know, Ray has a way of unzipping these guys. He asks them these questions and all this stuff tumbles out, and we find out stuff we would never know about without Ray's questions. Thank you, Ray.
You're welcome, Jay. I'm very pleased to be your Ed McMahon every Wednesday at 4 o'clock here on the internet. So you can join us and see what's happening in the energy world, and there is a lot going on. So join us every Wednesday at 4 o'clock.
Yeah, come around, be energized, right here on ThinkTech.
Here we are, Friday afternoon, 4 o'clock, or actually 4:30 by now, folks. Ted Ralston here, host of Where the Road Leads, and our fantastic guest, Dr. David Johnston from Duke University and ex-UH, ex-SOAST, and currently associated with Race for Water Odyssey. Is there anything else you do that we should know about?
Well, I learned how to do stand-up paddleboarding when I lived in Hawaii, so
okay.
I continue to do that in North Carolina where I live now.
All right, that's good.
Yeah.
You wouldn't find yourself doing that up with Chuck up north of the Arctic Circle, I don't think.
No.
Unless you wore one of those plastic-originated heavy-duty
Survival suits.
Survival suits, right?
Yeah, absolutely. I do a little work in the Antarctic where we have to wear those constantly. So.
Okay. You got a lot of history and a lot of experience, field experience as well as lab experience, teaching experience. This is a fascinating insight that you've been able to collect and then apply to the problem. The problem we're speaking of here is all the garbage collected in the North Pacific Gyre, the plastic component within that, where it comes, how it gets there, how it gets shorn and fractured, and then shows up on our beaches here. But what we were talking about just before break was the use of new technology to illustrate and highlight this old problem and maybe accelerate the understanding of it, accelerate the angst in the population to go do something about it, and maybe find some vectors here that we could press on to move forward. But I just wanted to introduce to you a piece of software that's available, which maybe before you leave, we can meet the guys who do it. And I'll just simply say that they basically rip apart the pixels into the 4 components, so you get zillions of pixels, but very fast, and then put perhaps 50 different filters on it, and then go through the filters in a sequential order to pick up particulate shapes, pick up polygons, pick up continuous curves, pick up hard edges, pick up color, no color. And it's done to look at blast effects in IEDs. So dealing at 10,000 frames per second frame rate.
Wow.
And giving you or the analyst a report saying, at this time, this subject is apparently in the video, but take a look.
Right.
So it gets the guy out of the picture and just tells him what the video is seeing. But the reason I bring it up is because we're thinking that type of technology is probably useful in getting beyond line of sight for UAVs, because this could be a cockpit, or not cockpit, but whatever we would call the nose of the UAV. It used to be called a cockpit.
Right.
And provide a high rate survey and scanning of all, and then extract the features out of the survey and scan so that straight things like telephone poles or telephone wires or other aircraft become evident in the resolved picture, and feed in the navigation system and then get the heading right. Because it would be of great value to you to have beyond line of sight, I would think, in these UAVs.
Yeah, and there's a lot of places where we can work internationally where we don't have to worry about that as much. So, you know.
Oh, we'd like to partner with you because we can learn from you what those issues become, and then design the software and the sense and avoid systems to mimic what it works.
Yeah,
and
absolutely.
Stay away from what doesn't work.
And we need to do a lot more of that, right? Because we do need to be able to progress so that we don't have to worry so much about those things. And that's important for commercial aspects, inspection, those kinds of things. But also really important for search and rescue, also really important for wildlife studies.
Well, it's really important for in the world of disaster management, which the Pacific, of course, knows very well what disasters are all about.
Yeah.
Disaster management is what the Pacific needs as resolution. Once again, right down the street here in high-tech Honolulu. By the way, Honolulu is turning into sort of a Silicon Valley version of a lot of high technology within a half-mile radius of where we are right now.
Oh, that's great.
But the National Disaster Preparedness Training Center is right down the street, and they're looking for every aspect of technology that can come into the picture in order to get better information sooner about what disaster situations have turned into.
Yeah.
And so that the response and the recovery and the rebuilding and the restitution can be done in a way that's quicker, faster, more intelligent, and return folks to their normal life patterns as soon as they can. So,
And safer too.
Yeah, oh yeah, and UAVs, be they rotor, the quadcopters or the fixed wing, are essential elements in that immediate future.
Yeah.
In fact, I suspect that what you are dealing with is you want to stay with the small, almost expendable level of UAVs that don't have a lot of transport issues getting them where you want to get them. And if you lose them, the day's not over. You have a spare and launch it up and go. And that's the same kind of a pattern that will likely emerge in the world of disaster management.
Yeah.
Small, inexpensive, expendable, throwaway.
Yeah, I mean, I would hate to think about them as expendable, but we, I have a vision of what the wildlife ranger professional might be, in the future, and you can imagine someone whose job it is to go out and patrol a particular area, count the number of frogs or a particular bird, and or say turtles on a beach, and so with them, as they walk their beach, they'll have their smartphone, which is linked to a database, and will be transmitting information about where they are and what they're seeing, maybe in near real time. And the other thing that they'll have is some form of drone, some form of unmanned aerial system that will allow them to extend their reach beyond the areas that they could walk to learn more, to collect more information. And those two pieces of technology will be linked together, and that is going to, that will change how we do things.
That's really an essential point here. I mean, it's a cell phone technology, or they're not phones anymore. They're computers with a lot of sensors on them.
Tricorders.
And radios and GPS receivers, all in what we call a cell phone. The concept of that becoming a payload in itself, whether it's in your pocket and you shine it or pick up an imagery that way, or stick it on the bottom of a UAV and go do something overhead. Or we had just last week had a request to go out and look at whales, and not just whales, but the stuff that comes out of them when they breathe.
Yeah.
And identify what the whale's been doing.
Yeah, you can learn,
So different
a lot about
sensors,
the animals.
but the beauty is this cell phone, that is a fully competent computer, and it can do the collect, it can do some onboard analysis, it can do the transmission, and even analysis and sorting can be done here. And
Absolutely.
you can make decisions about what sensors to use.
Yeah.
And it can be attached to a UAV,
Mm-hmm.
but it's still physically separate from it. So a failure here won't propagate backwards into the aircraft.
Right.
And a failure in the aircraft won't kill the sensor.
Yeah,
So-
these devices are worming their way into various aspects of my work. We also do a lot of telemetry work where we put tags on animals. And so we have a program in Cape Cod where we've been putting tags on gray seals. We capture them and we glue these tags on to their fur. They come off after a year because they mold. But those tags are archival. They collect information about where the animal goes. They have a high-resolution GPS, and then they also have a depth sensor.
They radio out, or you can just read them from remote?
Well, so they record that data and they store it while the
Okay.
animal's at sea. When the animal hauls back up on the beach to rest, it actually calls up the local cell phone network because it's got a cell phone in the tag. And then it FTPs that data over to our computers for us to be able to see.
So
where
when it gets within range, it downloads?
it texts us first, it says, I'm coming home.
I'm here.
Yeah, and then we get the data back. And so this intersection between smartphones, which I
Yes.
think drives a lot of our ability to make use of this technology, right? It's smaller, it's more efficient with batteries, has the capability to integrate sensors with all these different
And we do the
interfaces.
mission plan in here too, have
Yeah.
the mission plan in here. And then this is the very term we use in our work with NDPTC and others, is that on the disaster management side, we've got to get these UAVs down to be cell phone simple or screwdriver simple. So
Yeah.
we don't need a specialist to run them,
Right.
but they can be done with the level of sophistication that is represented by this type of technology, but by the simple user controls.
Yeah.
And so I'm intrigued by your idea. So we really need to collaborate and coordinate here at the university to university. And this is like a mind-expanding experience here. The fact that you guys are here with very similar thinking that we've got, and we got some experience that would feed back, I think, into you.
Oh,
and
absolutely.
we're part of one of these test sites that is
Right.
going to have a lot of flexibility in terms of how it can move forward. And most interesting, all this does work backwards nicely into the world of infrastructure management and operation, because the same systems, the same analysis work in infrastructure as they work in the remote extended domain you're involved in, and they really affect and can be used in the disaster management domain.
Yeah, so we need good communication to be able to leverage, breakthroughs in one area so that it can be used in others, because but there's definitely commonalities in those missions that we should take advantage of. Absolutely.
Have you been involved with I think it's called the UAS, Unmanned Aircraft System, Unmanned Air Systems Users Conference in Alaska that takes place in, I think, in September every year?
No, I have not, but I would love to go.
Well, we absolutely must get you there this year. There's two conferences in the U.S. world that are important. That one, and then the AVUSI
Right,
annual
which is just
event.
which
Were
is-
you down there?
No, I wasn't there. I was teaching and not able to go.
Okay.
But next year for sure.
Yeah, well, Margie and I were down there for our first time, and us and 10,000 other people.
Right. It must have been incredible.
Yeah, what you see down there is, at least what I saw, was a lot of high-end stuff. They were pretty much $100,000, $500,000 systems. There wasn't much focus on the really expendable, really low cost, low end.
Mm-hmm.
I guess that's because conferences don't necessarily generate attendance by manufacturers who are manufacturing something that's expendable. It's the big glitzy stuff that shows up at a conference.
I guess, yeah. But, like you said, for our applications, we're looking for things that are portable.
Portable, right? Transportable.
Transportable, that are lightweight, efficient in their ability, and allow us to change payloads so that we can do different things.
You just almost described the requirements function at the top of the food chain here. What we're doing right now is we're taking basically derived model airplanes in many respects, or model helicopters, and snapping various kinds of cameras on them and communication devices. None of them are optimized. I mean, we have, even a GoPro is a 2.5-hour camera, but batteries are only 30 minutes on the airplane. So we're carrying 2 hours of excess battery capacity, which means weight,
Right.
in the GoPro. Plus we're carrying the additional weight that's not needed for the structural aspects of it. If it's a focusing camera like a Canon S100, a very common camera in this
Yeah.
business, we don't need the focusing element. We don't need the heavy weight in the structure. Student projects and programs could pare weight down, could do optimization, and could start making these systems work together as if they were designed together.
Yeah, absolutely.
And that's what we need to work on. That's what we're doing at the university here.
Oh, that's great. Yeah,
And,
I think we should never underestimate the amazing power that students bring to a project. They have lots of ideas. They know a lot more about what we're working on than we do usually, and they also have a time limit, right? They have a deadline.
4 years, 4 and out, right?
Yeah, they have a deadline, and sometimes it's because they're working on a course, and so they have something to do within 3 months. And there's nothing better than having a deadline to motivate people to get something done.
Wayne Shroma in Electrical Engineering Department here, he heads the department at UH, has created a vertical integrated architecture program that allows students to enter at various levels, be with the program as long as they want, 4 years if they want, or less than that.
That's
and
great.
then move on, and other students plug in at the right time. The programs, the projects, and the team activities continue rolling long before and long after the students have been involved. So it's a continuous program that you can receive an inject of new students, and they just pick up where the other guys left off, and on we go.
Yeah.
So there's a lot of leave behind, and a lot of projects that spin out and add value.
Yeah, we do the same thing. In my lab, we have, working on the Race for Water project, I have master students that are working on data collection and data visualization, but I have undergraduate students that are doing some hardcore analysis. And yeah, so that kind of vertically integrated thing is great for training. It allows for older students to mentor younger students. It builds a sense of community. Lots of things that are really important to make the mission move forward.
This is a fascinating convergence. We got the convergence of all the Opala in the North Pacific Gyre. We have the convergence of a lot of technology and a lot of enthusiasm and interest and insight from the university level and other levels coming together to try to deal with that. And UAVs and unmanned systems and the analysis of the information they can collect is sort of a major contributor here. That's a great model for so many other aspects. And I'll just say again that applying what you're doing to our world of infrastructure management and especially in the Pacific with our strung out, over urbanized but disconnected environments, and then the disaster management for those kind of environments is a fascinating discussion for a follow-on time when you're back here in Hawaii again sometime, Dave. We'd
love to come back and
September of 2016, World Conservation Conference is right here. I think the vessel needs to be tied down in Cabela Basin, and we need to have this show again with you on it at that time.
Yeah.
So once again, Dave Johnston at Duke, thanks for coming on the show.
Thanks for having me.
Thanks for being part of this exciting development, and thanks for supporting the Race for Water Odyssey.
Yeah, my pleasure.
I'm sure without the support you give it, it would only be a sporting event.
Well,
And,
they're pretty impressive people, so
Yeah.
I'm really glad to be able to work with them and move along with them as they learn new things.
Great, and Hawaii will benefit from that as
I
well
hope
as
so.
other elements in the Pacific. So
I
thank
hope
you very
so.
much once again for
You're
being on
welcome.
the show,
My
and
pleasure.
congratulations on the future success of the program. And folks, we will see you next Friday when Where the Road Leads returns to the screen.